Today, we're going to dive into the really fascinating world of acids and bases. We'll be exploring the hidden properties of substances you probably use every single day. So let's get right into it. It all starts with a super simple question. We all know that different foods have different tastes, but have you ever just stopped and wondered, why? What exactly gives a lemon its tang or a bitter gourd its, sharp bite? That is the mystery we're going to unpack in this explainer. So to start, let's just explore this really familiar idea of taste and see where it takes us. Think about it for a second. From the moment you wake up, you are interacting with countless substances. You've got the fruits in your breakfast, the salt you sprinkle on your lunch, the vegetables for dinner. All of them have their own unique properties. And we can actually group these items by how they taste. It's pretty intuitive, isn't it? We naturally put things like lemon and curd in the sour category, sugar in the sweet one, and so on. This sense of taste is actually our very first clue to a substance's chemical nature. Okay, so things have their own taste. Got it. But what happens when we start mixing them? Like, if you add salt to lemon juice or even sugar, the taste changes completely. This tells us that substances don't just sit next to each other. No, they interact in some pretty fascinating ways. And that whole idea of interaction, that leads us to our next section, which feels a little bit like a detective story, the turmeric color mystery. This might sound really familiar to you. You spill something with turmeric in it, like a curry, on a white shirt. You go to wash it with soap, and bam, suddenly that yellow stain flares up into a bright red spot. What in the world is going on there? We can actually recreate this exact same effect with a super simple experiment. You just make a paste with some turmeric, spread it on a piece of paper, let it dry, and then just paint a little bit of soap water on it. Let's see what happens. And there it is. Look at that change. The yellow turmeric paper turns this distinct reddish-brown color the moment that soap solution touches it. Now, this isn't magic, it's chemistry. What's happening is that turmeric is reacting to the soap, and it's giving us a huge clue about its hidden properties. And this brings us to a really important idea. Substances like turmeric, they're called indicators. Think of them like nature's little secret messengers. They change color to reveal a hidden property in another substance. The fact that the turmeric turned red indicates something very specific about the soap. And hey, turmeric isn't alone. Nature is absolutely full of these indicators. You can actually do similar experiments using things right from the garden, like hibiscus or rose petals. They also change color when they interact with certain substances. Pretty cool, right? Now, while kitchen indicators are a lot of fun, scientists often need a more standardized tool. And that brings us to a very famous indicator you might have heard of before, litmus paper. Okay. The rules for litmus are actually simple, but they're incredibly powerful. Here's the deal. If you're testing an acidic substance, it's going to turn blue litmus paper red. And if you've got a basic substance, it does the complete opposite. It turns red litmus paper blue. It's a clear, simple test. So, using this litmus test, we can now confidently classify pretty much any substance into one of three fundamental groups: acids, bases, and neutrals. First up, we have the acids. The name itself kind of hints at their classic sour taste. And chemically speaking, they're defined by one thing: their ability to turn that blue litmus paper red. On the other side of the spectrum, we've got bases. These substances often feel kind of soapy or slippery to the touch, and they're the ones that turn red litmus paper blue, doing the exact opposite of what acids do. So what about the substances that do, nothing to the litmus paper? We call those neutral. They aren't acidic, they aren't basic, they're sitting right there in the middle, and they leave both red and blue litmus paper completely unchanged. Now let's connect this all back to some real-world examples. Things like lemon juice and vinegar, those are acids. That soap solution we used in our turmeric experiment, that's a base. And stuff like a simple sugar solution or pure distilled water, totally neutral. See? These categories are all around us. So we've gone from just tasting lemons to doing litmus tests. This brings us to our final big takeaway. You basically have a science lab right in your own kitchen. But before you run off to experiment, I have a very important note on safety. Just because something is in your kitchen does not mean it's safe to taste or mix randomly. So please remember these key rules. Never, ever taste an unknown substance. Always clean your equipment and always follow instructions carefully. Safety is number one, for sure. And that just about brings us to the end. What I really want you to take away from all this is that science isn't just something that happens in a fancy lab. The sourness of a lemon, a food stain on your shirt, these are all gateways to understanding the fundamental chemical concepts that literally govern our world. So what will you discover in your kitchen next?